All right, everybody, here's a video key for problem set 4.7. I've already completed some of it because some of it we probably did together already either on Class Kick or in class. But we have the SSS congruence postulate. So three sides of a triangle. So if we can show take all three sides, if we can show one side is congruent to another side, and then another side is congruent to another side, and the third side is congruent to the third side of two different triangles, then we automatically know those triangles are congruent. Okay, then we have SAS, which is the order in which these things are written matters. Like this is two sides, but then the angle has to be between the two sides, just like it's written here. We have a side and a side with an angle literally in between them, the way we write it. And so down here, we have a side, and here's the angle in between those two sides. Like this angle is not in between those two sides because this angle is between this side and this side. Okay, so it's got to be two sides and then the angle between those two sides. So we know this side is congruent to this side. We know this side is congruent to this side. And then we have an angle in between those two sides in both triangles that are also congruent to each other, which would prove that those triangles are congruent. Then we can do angle, side, angle, which is very similar. You have two angles, and then the side has to be between those two angles. So we know that this angle is congruent to that angle. We know this angle is congruent to that angle. So we've shown two angles are congruent. And then if the side between those two angles is also congruent, then automatically those two triangles are congruent. And then AAS also works. So you have two angles and then a side not in between those two angles. Okay, so we have this angle is congruent to this angle. This angle is congruent to that angle. And then that side is congruent to that side. So we have angle, angle, side, like that. Angle, angle, side. And then the reason that one works is because really you can just find this third angle because of third angles theorem. And if you have the third angle, then really you have angle, side, angle again, which is the same thing as number 3. Okay. And then what combinations don't work? Angle, angle, angle. Here's two triangles that have three angles that are congruent. I literally just took this one and copied it and then blew it up. So like you can tell they have the same angles. I can't get it exact because it does weird auto winding up things. But they do have the same angles, and they are definitely not congruent because one's way bigger than the other. And the other is SSA, which I already drew this picture, but we didn't talk about this in class. But the reason this one doesn't work is because you could end up with two triangles where one is this triangle. And then if you pick up this red side here and swing it over here, which is what I've done right here, so these two lengths are the same, you can see how we end up with two different triangles where we have this whole triangle like this. That's not what I wanted. Let's do this. So I have this whole, whoa, that's too big. So I have this whole triangle like this, and then this triangle here, but they still have three parts in common. They both have this side, and this angle, and then side, side, angle. But you can obviously tell that those two triangles are not congruent. Okay, so those ones don't work. And then one that's kind of different applies only to right triangles, and that is the hypotenuse leg theorem. So the hypotenuse is the side across from the 90-degree angle. So if you start at where the angle is and just kind of draw a line from the angle upwards that way, that's pointing to the side that's across from it. That's called the hypotenuse. So if you have two right triangles where the hypotenuse is congruent to each other, and then one of the legs are congruent to each other, just the legs are the other two sides. This is a leg and this side is a leg. All right, so let's go through some problems here. And here we're given an angle and an angle. So we could find the third angle, which means it's angle, angle, angle. And that's not enough information. That doesn't work because that's this situation right here where one triangle could be way bigger than the other. Okay, so that doesn't work. Oops, I'm on partial eraser. I'm going to use this as my handwritten key too, so I'm going to write very formally. The question is, can you definitely draw a triangle congruent to ABC? And I'm going to say no, because angle, angle, angle could result in two triangles of completely different sizes, even though all the angles are the same. Okay. And then this one, so let's draw a triangle here. A, B, C. It doesn't have to be a right triangle. I didn't even mean it to be. In fact, let's just, how do I do this? We'll make it not a right triangle. There we go. All right, so we have side AB is 5, side BC is 12, and side AC is 13. Not drawn to scale, meaning the sizes might not match up correctly. But this is just side, side, side. And so yes, we can do it. We can find another triangle that's congruent to that one just by making a triangle that has the same 3 side lengths. All right, let's draw some other triangle here. Give it some labels again. A, B, C. Angle A is 55. AB is 4.5. And BC is 6 3/4. So this, though, if you look at it, we have side, side, and then an angle. Side, side, angle doesn't work. So we'd say no. Side, side, angle doesn't work. On D, let's draw ourselves another little triangle here. ABC. It doesn't matter what you call ABC, just label the picture accordingly based on the given information. C is 48 degrees, B is 67 degrees, and AC is 3 1/4 inches. And so now we have, if we start here, we have angle, angle, side. So with angle, angle, side, yes, we can do it. You could also find the third angle and then do side or angle, side, angle, which also works. So that's up to you. All right, on these problems, we want these two triangles to be congruent. So what information will we need in order for these to be congruent? If we have AB congruent to DE and CB congruent to FE, and I want to use side, 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 sorry, those are congruent. So if I want to use side, 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 then I have to show that these two sides are also congruent. So AC congruent to DF. Okay. And then we have, now we're going to use side, angle, side. So we have angle A is congruent to angle D. CA is congruent to FD. And so if we want to do side, angle, side, we have side, here's angle, so we need these two sides to be congruent, which would be AB congruent to DE. All right, and then on C, we want side, angle, side, and we're given angle B congruent to angle E. AB congruent to DE, so if we want side, angle, then we need this side over here. So those two would need to be congruent, which is BC congruent to EF. Okay. And we're going to do a similar thing down here on number 3. Let's make triangles congruent using AAS. So we have GH is congruent to MN, and angle G is congruent to angle M. So if we want angle, angle, side, it can't be this angle because then the angles or the side is between the two angles. So we need to show that these two angles are congruent. So angle F congruent to angle L. And then we want to use angle, side, angle. And we have FG congruent to LM, angle G congruent to angle M. So angle, side, angle. So we have, it wouldn't be this angle because we don't have the side in between the two angles. If we use this angle, this would be angle, angle, side. We want it to be angle, side, angle. So we're going to use angle F and angle L. Because now we have angle, side, angle. So again, it's angle F congruent to angle L. Oops. And now we want to use side, angle, side. So FH is congruent to LN. Angle H is congruent to angle N. And if we want side, angle, side, then we need that angle to be between our two sides, which means we would need GH to be congruent to MN. Okay. So that's what's going on in those problems. Now here's an example already done for you. But basically we're going to find two triangles that are congruent, say how we know they're congruent, and say what transformation resulted in that triangle. So here we know that this side is congruent to itself, and the two triangles share that side. And so we have an angle, a side, and an angle, and then we have angle, side, angle. So we have this angle and this angle are congruent, this angle and this angle are congruent, and then the side is congruent to itself because it's the same side. And so that's angle, side, angle. So we're using angle, side, angle. And now remember, the order in which we say these things matters. So we can say triangle. If I start with, like, let's say this angle, the single angle, so that's C, and then AE, that has to be congruent to the same starting angle where, like, it has the same measure. So it would be angle or triangle E. And then I went over to A, which is which is congruent to K. So I'd say EKC. Okay. And then the transformation that happens is, since this angle is like down here, it's not just a reflection, because a reflection would put this angle into the same spot that this angle is in, like this angle. So it's got to be a rotation. So if you took this whole triangle and like were able to spin it this way, maybe you can see how it would create the same triangle. Okay, here we have side, side, angle. So we can't do that. No. SSA, bad, no good. Get out of here. All right, D. Now we got to do a little bit of work here. Remember, this means these are parallel. So we have this situation going on right here. Remember, like these Z's. So that is alternate interior angles, tells us that this angle is congruent to this angle. Okay. We also know that these two angles are congruent because they're vertical. And we can also do alternate interior angles this way to show that these two triangles, or to show that these two angles are congruent if we wanted. So we have three angles, but that's no good. Angle, angle, angle never works. What we need is, we can do this one two ways. We can either do angle, side, angle, or we have angle, angle, side. And then down here we have the same angle, same side, where all those are equal. So either one of those you could have probably come up with. So I'm going to say angle, angle, side, or angle, side, angle. This one's again a rotation because like this angle would have to swing down to here. So it's not a reflection. And it's not just shifted left, right, up, or down, which would be a translation. And then our congruence statement, let's say it's triangle SMI. So I can name the first triangle however I want. SMI. I could say ISM, whatever. But then the second triangle has to correspond to that. So angle S is congruent to angle E. So I had to call it triangle E. Then I did the single angle label that I did. So then it would have to be L and then I. Okay. E. So now we have this side congruent to itself. And so we have side. This would be a 90-degree angle. So we have side, angle, side. Okay, so side, angle, side. Now this transformation is a reflection because this angle would have to be congruent to that angle. Or this side is congruent to that side, so it just got flipped over is actually a better way to do it because we didn't know about those angles. So this is a reflection. And then our congruence statement, again, just, I'm going to say triangle, let's say MAT. So I did MAT, so then I got to do MHT. It's got to be like the same order. They got to all correspond. The congruent angles have to correspond to each other when you're doing your labels. Okay, F. Now we have a right triangle here, so that should scream at you what we're going to do. This is going to be hypotenuse leg. It wouldn't have to be, I guess, but here's our hypotenuse. They're congruent to each other, and then one of the legs are congruent to each other. So this is hypotenuse leg theorem. This triangle is just moved over to the right, so our transformation is a translation. And our congruence statement, we can say triangle, whatever you want, MAX if you want, is congruent to, so I went MAX, so I got to go JEF because those are the angles that are congruent to each other. Is congruent to triangle JEF. Okay, and then G. It says T is the midpoint of RY. That tells us that these two are congruent. Okay, if those two are congruent, then what we have is angle, angle, side. Angle, angle, side, where those three pieces are congruent within the different triangles. So we have angle, angle, side. And we can say triangle PRT, let's say. So if I went PRT, then I got to go AYT. Remember, the corresponding parts have to be congruent. So AYT, and this one again is a reflection. And you might be able to tell on H right away, if they are in fact congruent, which I'll save you some time and tell you that they are, that our transformation is also a reflection for this one. Okay, let's figure out what is going on here though. We know that this side is congruent to itself. And here it tells us that LV bisects the angle OVE. So that means this angle is congruent to this angle. So now what we have is we have angle, angle, side. And then we have angle, angle, side again. Okay? And both triangles, so those parts are congruent. So we know it's angle, angle, side. And let's say triangle LOV. So I went LOV. So my congruent parts to L are LEV, because angle E is congruent to angle O, so they both have to be like the middle letter. So angle L, triangle LEV. And then I. So this side is congruent to itself. So this is side, side, side. Again, it's a rotation because this is up here, but that's down there, so you'd have to rotate it to get it to the other spot. And when I'm writing these congruence statements, there's like three potential answers for all of them. It just depends on which letter you write first. So I'm going to say triangle ARM. So I did A, which corresponds with Y, so it's going to be Y. And then R, I went like on the double marked side, so I have to go this way on this one. Okay, so it's YMR. That way my sides line up that way. And then this one, we have two angles. These are vertical, so we know they're congruent. So we have angle, 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 which is no good. That doesn't work. Angle, angle, angle does not tell us anything about congruent triangles. And then that's it. Peace.